Okay, so now we've calculated the entire probability distribution for this experiment using our tree diagram. And actually we've answered our original question, which was, what's the probability that we get a red followed by a red? What's the probability of that particular event? And that corresponds to just a single outcome on our tree diagram. So it corresponds to a single path on the tree diagram. So we can calculate that probability by multiplying the probabilities along that particular path. Okay. Now what if we have a more complex event which corresponds to more than one outcome here? For example, what's the probability that the second marble is blue? This is a little more complex. There are two paths in this event. Both end in blue, so the path where we first draw a blue and then secondly draw blue is in there, and also where we draw a red and then draw a blue. And as before, when we had a probability distribution, we identify the outcomes in the path and we add their probabilities. So we identify the paths corresponding to this particular event. We multiply the probabilities along these paths to get the probability of the paths individually, and then we add their probabilities to get the probability of the entire event. So the probability that the second marble is blue is the probability that this path happens, plus the probability that this path happens, and we've already calculated those. That's the product of the probabilities along this first path plus the product along the second paths, 24 over 90 plus 12 over 90, and that's 36 over 90. Okay, tree diagrams are pretty easy to draw, but let's just recap on a few rules for construction, just things to keep in mind when drawing them. So when you're drawing your tree diagram, the branches emanating from any particular node should represent all of the possible outcomes in the next stage of classification, or in the next experiment if you're doing repeated experiments or repeated trials. The sum of the probabilities on all of the branches emanating from any particular node should add to 1, because they represent all of the possible outcomes in the next stage of the experiment. And we label these paths with the appropriate conditional probabilities. What are our rules for calculation? Well, each path corresponds to some outcome for our big experiment. And the probability of that particular outcome is going to be the product of the probabilities along the path. If we have a more complex event, E, we identify all of the paths in the event E, calculate the probability for each one individually by multiplying the probabilities along that path, and then add the probabilities of those paths. How do we use this to choose a strategy? Well, tree diagrams are very useful for choosing strategies which maximize the probability of winning or maximize our expected gains. And in some situations, our only opponent is chance itself, and in some situations, we actually have an opponent which makes choices. So we and our opponent make alternating decisions, as in, for example, a game like chess.